Hello, everyone. Welcome from California and welcome to day 3 and panel 3 of the exciting Imagine 2021 3-day conference. We've learned quite a bit during day 1 and day 2, a lot of technical information, a lot of interesting applications from partner companies. So really exciting to see all this ecosystem showing their latest and greatest during these 3 days. At this panel, we are not going to touch on the technical details, but rather we are going to focus on the opportunity side of TinyML. And one thing that kind of blows my mind away is this kind of dilemma I keep running in my head, which is on one hand, we have tiny things like this. This is like a tiny device we develop and commercialize here in Qualcomm. It's like the size of the grain of rice. We have these tiny devices on one hand, obviously this tiny software, tiny things, and then we're talking about this massive opportunity for TinyML in this decade. So this tiny, massive team, I think it's actually quite interesting. So I am delighted to introduce my panel today. We have an amazing group of people and also a very diverse group of people. So in no particular order, it's Wei Zhao from NVIDIA. So Wei is leading the emerging areas in NVIDIA, a very interesting area. So then joining from Singapore is Lianzhu Su. He is from ABI Research, and he is going to get the prize for the late joining this. So what time is it in Singapore now, Lianzhu?
It's 12 midnight.
Oh, yeah. Thank you for joining us on Saturday morning. Effectively Saturday morning. And then joining from UK will be Alasdair Alan from Raspberry Pi. And his LinkedIn profile says he's a scientist, he's an author, he's a hacker, he's a maker, and he's a journalist. So this is a perfect qualification to join this panel. So he's qualified to be here, and we are happy to have all of you here. And let's start the discussion. So my first question to the panel is if you can introduce yourself more so from the way you joined the TinyML community. What is your journey there, and what keeps you excited about TinyML today?
I can get started. So I think I started my TinyML journey as a TinyML Global Meetup Committee member. I remember we hosted our first meetup in the San Francisco Bay Area. That's over 2 years ago in June 2019. I have to admit that I was skeptical about TinyML at that time. How could you run machine learning on a tiny microcontroller? I thought maybe 30 people would have shown up, but turned out to be more than 130. That's the first time I learned about Google's TensorFlow for light micros, Kixel, AutoML. I have to say, I was not disappointed. I got blown away with all the possibilities that TinyML could unlock. And, I have been witnessing the TinyML exponential growth ever since. I think there's a second part of your question, what keeps me excited? There is an engineer in me. So all the technical advancement in this field get me excited. We can talk about power efficiency one day, then model compression on the other day. I felt that I was like the kid in the candy store. There was never a dull moment in the past 2 years.
Great, thank you, Wei. And I assume you're not bored at NVIDIA now with TinyML.
No, I'm trying to bring awareness, TinyML awareness to NVIDIA as well.
Okay, so shall we go from west to east? I think Alasdair, you're next in the UK.
So I actually started with machine learning back when it was still called neural networks in the very early 1990s, the first time this was popular. I was using neural nets for Earth observation satellites, and I actually built one of the first video compression software stacks for black and white video phones when it was still hardware video phones with like 100 pixel by 100 pixel like LCD screens. And that was all built around neural network stacks. But I think it's more recently, a lot more recently, it's the arrival of hardware able to run machine learning models at vastly increased speeds inside relatively lower power envelopes without needing a connection back to the internet that's really changed things for me. And I think amongst this audience, I'm probably best known for the benchmarking work around the new generation of ASIC acceleration hardware. And I think that's the thing that really excites me, the ability to work with data in a privacy enhancing way right at the edge in real time. That's the thing that excites me right now, I think.
Oh, that's great, definitely. And now moving on to the Far East, Yanju. So what is your background there?
Yeah, thank you. So you can call me LJ as well. I'm a principal analyst at ABI Research, but my sort of main coverage area is actually Edge AI. So when I first covered AI, it actually coincides with the rise of Edge AI, and in particular TinyML. So I think probably most of the attendees here will be aware that ABI Research has been sort of publishing a couple of research papers on the potential of TinyML market. And I think one of the things that we have seen with TinyML, and also what keeps me excited, is that the enormous possibility of having AI being run on multiple devices with extremely high accuracy and low power consumption. And that sort of is what we see as the one of the catalysts for the next decade of AI evolution. So as a technology analyst, I'm extremely excited by this.
Great. Well, thank you for this introduction. And so as you can see, we have a very diverse panel looking at this opportunity from different angles, from the emerging market, that's way, in the developer community, I was there, and more like from the market numbers from LJ. And as to myself, my name is Evgeny Gusev again. I am from Qualcomm AI Research, based here in the Bay Area, and I am actually one of the founders of TinyML Foundation and currently the chairman of the board here. So really excited to see this community growing and help this community to grow to the big numbers which we're going to discuss today. So before we'll talk about the big numbers in 5-10 years, let's kind of calibrate where we are today. Just like last year, I'm a scientist by training. My background is physics. So let's kind of see what our reference point is. Like, can you think and can you describe maybe in one sentence where we are with TinyML today, kind of, so we can extrapolate later into the future? I mean, we need to have this reference point to see.
I mean, I think we're at the very earliest days. I mean, to go to two sentences, the end goal is smart dust, right? And we're a very long way from there.
Okay, that's a good way to describe it. So LJ, you have an opinion there? You have the numbers, you have all the graph, all the plots, right?
Yes, and we have just updated it as well. I think based on our estimation, the total size of the market by the end of 2021 will be probably around 750 million in total shipments. But we do foresee that number to grow by at least 4 times by the end of 2026, about 5 years from now. So it's an extremely promising market, but there's still a lot of work to be done here. I mean, we still need software support, we still need developer support. And I think that's why we have all these amazing panelists here to sort of discuss that, how we can incubate this community and then try to push it further.
Great. Wait, what is your take? What is your observation?
Yeah, I think my observation is totally aligned with what the other panelists mentioned. I think TinyML is still in its infancy stage, but with explosive growth momentum. I would love to add some of my personal experience here. I'm honored to be one of the technical program committee members of TinyML Asia, both last year and this year. While engaging with the silicon partners in that region, we're observing the surge of AI accelerators and application-specific TinyML hardware coming to the market. I think that's an indicator that waves of new TinyML applications are approaching as well.
Yeah, no, that's great. I think, and that's I think what I want to address next, the application side of things, because you're right. I think on one hand we have a lot of silicon coming to the market. That's great. On the other hand, we see a lot of software tools available and kind of becoming more and more user-friendly, and like AutoML tool, neural architecture search type of tools, more data available, and so on. So this is all great. This creates very solid foundation. And then the panel before addressed also the people side of things. And I think this massive experiment that what we see coming out of edX and Harvard and Coursera and many other places, Seed Studio and so on, creating this massive pool of talent coming into the field. So we have this kind of massive momentum, tools, hardware, and then people. So what is the missing piece? I mean, how do we get from where we are today to these billions of devices? What LJ mentioned earlier. What are the industries? What are the applications that are going to drive that?
I mean, I think from my perspective, there's two real use cases for machine learning at the edge for TinyML, which is the first one is privacy. We've lived in an era of big data for 10 years, 20 years now. Or how long has this gone on for? It seems too long. And machine learning to me offers the possibility of moving beyond the big data era into an era where we get back our privacy, because the companies that want our data, that want to be able to interact with us in a sort of semi-automated way, can get the data and then act on it in real time at the edge without having to have this huge data warehouse or data lake or whatever they're calling it these days. That is essentially write only. It's very rare to go into these huge piles of data and do anything with them, anything substantial. And I mean, I think the other real heavy duty use case, which I'm seeing a lot, is that, for 10 years, software has been eating the world, and now machine learning is eating software. We're using machine learning to fix legacy hardware in the field, to monitor mechanical dials and readouts remotely. We're automating the world with machine learning, because machine learning networks and bits of hardware are cheap and very patient, and humans are not. I mean, that's the smart dust goal that I talked about. Putting computation into the world.
Yeah, well, I mean, definitely, I think the digitizing of everything is really a very strong momentum. Whether we want it or not, it's happening. But then you're right; it has the flip side of this is the privacy, because whether you want it or not, your data is everywhere. So I think TinyML definitely offers this kind of unique opportunity to keep the data with the owner of the data, whoever the owner is, either an individual or a farm or superstore, supermarket, or whatever. So that's actually quite unique value proposition. Yeah. So LJ, I'm sure you have tons of data from your analysts, because I know you talk to a lot of customers, a lot of industries. That's kind of where you get the source of your data, the source of your inspiration. Kind of what is your finger on the pulse of the industry today?
Yeah, so I think I concur with what Alistair has mentioned earlier. The sort of the privacy-focused applications will be one of the sort of major driver, and that actually coincides with the rise of smart devices. So I think the desire to have TinyML being embedded across multiple types of smart devices, it's actually one of the key drivers, and that's where I see TinyML to be dominant in. I will still be led by mostly consumer devices, but slowly it will then trickle down to the industrial applications. I think, in my personal opinion, if I were to sort of to nominate another sort of major sort of killer apps for TinyML, there will probably be ambient scene recognition. If you kind of think about it, that the ability for devices to process data immediately at the edge to sort of, I think there are three advantages to this application. You are able to satisfy the low latency requirements for majority of the AI application out there. Secondly, you are able to provide contextual information for different type of decision making. And then thirdly, it's extremely useful for all types of devices, be it stationary or mobile devices, like robots or autonomous vehicle. So the smart devices that's out there will require at least some level of capability to digest the scene around them and to make decision, like immediate decision, without sort of the need to go back to the cloud, the need to go back to the server. So that's where I think TinyML will excel and will eventually proliferate.
Yeah, no, that's exactly how we define TinyML. Do you have any specific examples like in those areas, either contextual or industrial, like really kind of the big applications where we see good tractions today and kind of double-digit or maybe triple-digit growth into the future? Any specific ones there?
Yeah, I think one of the major ones that we are seeing right now is obviously having that ability to amplify or remove sounds in sort of true wireless earbuds, or sort of being able to recognize the environment that you are in using our smartphone or smart home devices. So that's sort of like the major application at the moment. And also we are seeing sort of field devices, so industrial or machinery that are able to either perform predictive maintenance or be able to sort of do like overall efficiency enhancement just based on the sound that they collect, based on the simple image data that they can collect and process at the edge.
Yeah, okay, that's good. So Wei, what is your opinion on this?
Yeah, I think I want to take a different direction here and address something more fundamental. Evgeny, you already touched on this, but I want to re-emphasize development tools. So think about web development. At one point, I remember web developers have to learn CSS, HTML, JavaScript in order to build a sleek web page. Now with tools like WordPress, everyone can spin up a content page, even you are not technically, literate. So I think similarly, platforms like Edge Impulse significantly lower the bars of entry to build TinyML applications. My data here may not be accurate, but I remember there are at least 30,000 projects powered by Edge Impulse platform right now. So think about the number of applications we will be able to unlock with development tools like this.
Yeah, no, go ahead. Yeah, go ahead.
Picking that up, it's like when I was doing the benchmarking work, I literally could not find a tutorial online on how to do a really simple inferencing with TensorFlow Lite for microcontrollers. It just there was plenty of how to train your models, like how to train models, and then there was no tutorials on how to use those models. And I mean, to a certain extent, it reflects the background in the state of the industry, right? It was coming from an academic background. It was just like people were training models to improve the performance. But for a developer perspective, that wasn't really that useful, right? And so the appearance of things like Edge Impulse and sort of other tools to simplify, not just training, but using the models in the field actually on hardware is a big step.
Yeah, that's an excellent point. And actually made me thinking a little bit of the topic here. But I've been curious. There are ways to benchmark hardware, right? And there are different ML perf and other type of things. How would you benchmark these tools? I mean, how do you compare, let's say, Edge Impulse to SenseML to Kixo to any other type of company? Is it like easy to use, number of likes?
I mean,
if I'm a newcomer, like, what tool? I mean, we are going to have a separate workshop at TinyML on all this of ML tools. This is kind of a little bit more thinking forward about this. But how do you benchmark? Again, a little bit off the topic, but maybe you have some thoughts there.
I mean, my initial thought is like, what do you want to measure, right? I mean, it's not just training type. No one that's actually going to use a model in the field cares how long it took to train. That's just not a relevant statistic, right? So you see a lot of benchmarks around this model here. This is the training time. No one cares. Not developers, not people that are going to use TinyML. People, so TinyML researchers and developers are not the same demographic.
Yeah.
So you say it must be inference speed. Inference speed must be the most important thing, and that absolutely is what your benchmark should measure. Well, maybe. But if it's TinyML, it's on embedded hardware. Where is your embedded hardware, and what's what's the power flow through the hardware? What's the environmental impact of the hardware? What's, how, there's a whole bunch of things about where your machine learning is heading, like where you're going to embed it. What is it going to be used for? What is good enough? There's I tend to call this capable computing, right? There's Intel, for instance, has been more locked for years into this Moore's law progression, and we all know Moore's law is dead and gone, and it's totally broken. So performance is no longer the thing. It's like, is your computing good enough to do the job that you want it to do? I mean, 20 years ago, when someone came to me and said, what computer should I buy? I'd say, what do you need to use it for? Like, are you going to store lots of documents? So you need the one with the big, and now it's just like, what color do you want it to be? It doesn't matter. Like, this is why all the new Apple machines are different colors, because that's the only differentiator now. Computing is capable. It's good enough. And TinyML machine learning, we're not there yet. We're still at the stage of, well, what do you want to use it for? You can't just go, I'll use the one that comes in the blue package. You have to decide what your use case is, and then tailor your machine learning to that. So benchmarking is not a trivial thing. You can't just measure one statistics and say this is the best one.
Yeah, definitely we'll have more discussion on the benchmarking and TinyML events, and also on the tools as well, because that's kind of a very fast emerging area, which is very important, like Wei stressed earlier. I think the tools and developers, that's extremely important. I want to get us back onto the massive opportunity side of things. And this is my favorite question. I ask it at every panel, and I never got the same question. So it's always different type of questions, and that's what I love about it. We discussed many different driving forces and verticals and so on. So if you pick one killer app and kind of this hockey stick timeline for this killer app, what would it be? Again, just one killer app, and when we are going to see the hockey stick for this killer app. So LJ, maybe you can start. You already have this data, so you can share them with the audience.
Yeah, I mean, I think I've touched on it a little bit just now. So it's, I think, to me personally, it's going to be ambient scene recognition, and I would use that. I'm being seeing that emerging across both consumer and industrial devices, and I think this type of application ingests multiple type of data sources. So at the end of the day, it's almost a data agnostic, if you ask me. It's really about how do you want to use it, what do you want to use it for, and sort of and that is sort of ultimately the prerequisite to be a killer app is to sort of be as agnostic as possible in terms of hardware, software, and the use cases.
And so basically it's audio and vision, kind of scene recognition, ambient recognition type of thing, right?
And time series data as well. So if you can take in pressure, temperature sensor, even, I mean, if you push it further, people are using gas sensors, perhaps. You can build an artificial nose to detect sort of poisonous gas around you. There are sort of tons of use cases that you can actually develop with that.
Okay. And time-wise, when are we going to cross the 1 billion bar for this type of application?
I would say pretty soon. I think we have seen, obviously, Qualcomm and the rest of the hardware industry has been pushing really hard into this domain. I think guys, the MCU guys, NSP, STMicro, I think with sort of the growth around developers community, and then obviously the tools that comes with it, like edge impulses, I think those are extremely helpful for sort of pushing towards that 1 billion shipment.
Cool. And Wei, what is your take?
Yeah, I'm more thinking along the lines of application category. I want to double down on healthcare. So I worked for ARM before joining NVIDIA. I remember one of the ARM customers built this asthma inhaler. At the heart of the device was, of course, ARM cortex-m microcontroller. So the processing power of the microcontroller itself enables the intelligence and also connectivity. So patients were able to use this inhaler to monitor real-time information such as the inhalation, lung capacity, flow rate, those kind of information, and share with their doctors in real time. I think also because of the pandemic we're still in, that telehealth becomes a new thing. So this also falls into the category of the privacy enabled applications that the other panelists talked about earlier.
Well, this is a great point, and thank you, Wei, for taking us into this direction, healthcare and what role TinyML can play there, because it's definitely massive. I think we have 7 billion of people, everyone cares about their health, a lot of opportunities. Some of these devices can be disposable because they're extremely low power, low cost, that type of thing. And this inhaler is just one of them. In fact, I think we filed a patent on this in Qualcomm about 3 years ago under my name, since you measure there. So I would like to see more of those in the market. So I might get some royalty from that.
Can I ask a question though?
Sure, yeah.
Eugenie? Yeah. No, the healthcare is definitely one of the sort of like the most exciting domain for ML. But I'm just kind of curious from all the panelists' experience here, is it difficult to get approval to deploy AI or ML-based solution in healthcare? Because I'm sort of under the impression that it is a tightly regulated market, and then it's fairly fragmented as well, depending on the jurisdictions and the borders. But just kind of curious there.
Yeah, I think I have kind of my own personal experience, if I can answer quickly, from Qualcomm. So there is a perception that it's hard, and it is hard in a way, but there are different ways of healthcare devices. Some of them are really medical grade, some of them are wellness grade. Wellness is easier. That's kind of one short answer, and it's really doable if you want to do it. And I think now these days, actually, FDA is more open to do this kind of things. And second, FDA, we're talking about US. I mean, the rest of the world is very different. If you want to implement this type of device, for example, in China or in other parts of the world, then the bar is much slower. So you can get this there. And I think we're going to see more devices there. So any opinion from yours there or Wei?
Yeah, I just want to add one thing, because hearing aids, now a lot of companies began to add a TinyML capability to hearing aids. And in US, actually from this year, hearing aids will become available over the counter. So that's a new window.
It's moving classification between, oh, that's interesting. I didn't know that. Huh.
Yeah, okay. It's this year. Yeah, I can share more information, but I was chatting with this company in Taiwan. The founder of the company, he is actually hearing impaired. So he'll build, machine learning capability, actually, I think on top of a Qualcomm SoC in order to extract the voice from all the background noise. Very interesting use case.
I mean, I think for my own thoughts, I think that it's along the similar lines of the ambient stuff. I think predictive maintenance is going to be absolutely huge and is going to absolutely hockey stick within the next couple of years. Totally. And I can't remember who said it earlier. One of you guys said it, which was that it was the home uses you said was the more popular, and I was actually quite stunned by that. I was like, I would think that the industrial takeoff would be far. It's a low-hanging fruit, right? It's like, and they have the money to deploy hundreds of sensors. I would have thought the industrial uses were far more prevalent, and amongst that, predictive maintenance is really the obvious thing. But yeah.
Excellent example. So I think we have 1 minute left, and I think I would like to cover one very important question, because I mean, we all work for companies, we all get paychecks. But there is one angle of TinyML, which in my opinion is extremely important for all of us, which is the social impact. Kind of my personal journey, I'm super excited and super passionate about TinyML, but kind of my first wave of excitement was coming from the commercial application of this market opportunities. But more and more I think about TinyML these days, it's really the social impact that keeps me up at night, really, and how TinyML can change the world for good. I think we have maybe one in a lifetime type of opportunity to change it in a big time. So it's really, I mean, we talked about AI democratization before. So in terms of the social impact, what does it mean for you, and how do you see TinyML changing the world for good. And yeah, I think that's really a great area for us to elaborate.
I mean, privacy. I've said it before, and I'll hammer it on again. Privacy is the huge opportunity that it gives us. I mean, to counterweigh that, I think it gives bias is a huge stumbling block, especially on sort of local minima trained networks where you know the bias is built into our own biases, and I think that's a huge stumbling block that we have to do work on. I mean, that's why I think industrial applications might be like the early wins, because putting TinyML into the biomass, so like exposing it to biomass, as I put it, has problems.
Yeah.
So like humans and machines like sometimes have problems. So, but privacy is the absolute big win for me.
Definitely. So LJ, what does it mean for you, from your part of the world?
Yeah, I think the sort of obviously I think it will be an easy brownie point to score if I would just leverage Wei's point on healthcare and hearing aids. I'm not going to do that. Just gonna say, I think with the proliferation of TinyML, one of the key benefit is actually in the augmentation of human workers, as well as of the sort of protecting their safety at the end of the day. And I think increasingly we are seeing sort of large numbers of cameras and machine vision devices being deployed in mines, in industrial sectors, on assembly lines to sort of protect workers from hazardous sort of working environment. And I think we've sort of we've extend that into sort of the work that they done on a daily basis. I think we can immediately see sort of not just the conservation of human life and health and welfare, but I think we are also seeing a lot of the TinyML now being deployed in actual sustainability and sort of environmental initiative. I think we are already seeing sort of cameras being deployed for forest conservation, for animal conservation. I think we're going to see more and more of that, because those areas are naturally sort of a little bit underfunded and always trying to find ways to maximize their existing resources. And I think TinyML has a big role to play in those domains.
No, that's great. And Wei, you have a very unique position because you're based here in the US, but you interact a lot with the rest of the world, in China, in Africa.
Yeah, across geo. Yeah, I think TinyML for Good is really baked into TinyML's ethos. We have been talking about healthcare, education, conservation. Because I work with a lot of developers in Africa region, I would love to use one of their use case. And even if our audience here have been long enough with the TinyML community, you probably heard about this. It's a project built by TinyML Kenya community, because beekeeping is a major economic activity over there. You know, in Kenya alone, there are over 90,000 bee farms. However, you know, parasite infection, even human thefts were causing a economic loss, as much as like 19 billion annual losses in local currency. So this group of developers began to use ARM cortex-m based devices, embed them into the beehives to collect the temperature, humidity, vibration sensor of data, and triggers messages to farmers' mobile phones when anomaly is detected. And the solution has been deployed to over 100 farms and will scale up later this year.
Oh,
I think that's an excellent use case, explanation of how TinyML for conservation is playing a significant role here.
Great, thank you, Wayne. Thank you for joining my passion on TinyML for social impact and for also AI democratization, which we didn't talk too much about this. I thought I'm a dreamer, but apparently I'm not the only one. So I hope there will be more of us. And by the way, we're going to have TinyML for Good workshop on November 17th, specifically talking about this type of topics. So I think we are out of time. I would like to thank you, our panelists, for sharing their great insight and really kind of showing they believe in a massive opportunity for TinyML for the fundamental reasons we know. It's the power, it's the privacy, it's kind of the way it can change the world. So I think we'll have this panel in a couple of years and we'll see where we are, or maybe sooner, but definitely it's great to see this explosive growth and be part of this community and drive the killer use cases. Thank you again, and we'll see you soon.
Okay.
Thank you.
Thank
Thank
you.
you.
Bye.